Greetings to all. This video will serve as an explainer and demonstration video of our final year capstone project for the academic year 2021 to 22 here at PES University. Our project aimed to develop a semi-autonomous smart wheelchair under the guidance of Associate Professor Asha Patil. Our team consists of Tavishi Bansal, Tejas Piyu, Rishabh Kushalappa and myself Chirage. We would like to thank our guide Asha ma'am and the panel members Venkatarangan sir and Vishwanath sir for their guidance and support. We would also like to extend our gratitude to the HOD of EEE Department Dr. Keshavan sir, the Chairman Dr. M.R. Doreswamy sir, Pro-Chancellor Jawahar sir and the Vice Chancellor Dr. Surya Prasad sir for providing us the opportunity to conduct this project under PES University. Now, independent mobility is a key component in maintaining the physical and psychosocial health of an individual. Further, for people having disabilities or the elderly might require mobility support, and that could restrict their freedom and make them feel like a burden to another person. Though manual or electric wheelchairs are satisfying for most of the low and medium level disabled cases, however, in severe cases, it is impossible or very difficult to use these wheelchairs independently. Hence, our project aims to eliminate these independence problems, at least in interior spaces, by making an electric wheelchair semi-autonomous, drawing inspiration from the industrial line follower robots. Line following is one of the most important aspects of robotics. A line following robot is an autonomous robot which is able to follow a black line that is drawn on the surface consisting of a contrasting color. This line follower theory can be utilized in achieving an autonomous wheelchair. This research project presents a semi-autonomous robotic wheelchair that is designed to move automatically and follow the line. Our wheelchair in autonomous mode will detect any color track between black and dark grayish colors over a light contrasting background. The wheelchair can support an individual weighing 80 kilograms and can reach up to a safe speed of 4 kph. The system mainly consists of Raspberry Pi as the heart for computer vision. Interfaced with it via I2C protocols is the 7-inch Raspberry Pi touchscreen which serves as the control panel and the display unit for our wheelchair. A webcam with inbuilt microphone is connected to the Raspberry Pi using USB for detecting the predefined black line and for remote video streaming. This whole setup is powered by a 10,000 mAh power bank. The Arduino Uno serves as the slave microcontroller and performs motor manipulation operations based on the commands received from the master Raspberry Pi. It is interfaced to the Pi via 3.3V to 5V logic level converter and makes use of UART communication protocols. The Arduino is connected to a dual channel 12A Sabertooth Motor Controller which is set up to be used in simplified serial mode, and again this communication too uses the UART protocols. The motor controller is connected to two 24V 250W PMDC motors which are hooked onto the rear wheels of our wheelchair to work as a differential drive setup. To the Arduino, two optical sensors are interfaced and are mounted on the either side at the front of our wheelchair to detect obstacles and come to a halt until the obstacle is removed. We also interfaced a buzzer to the Arduino to go on when an obstacle is in the path of traversal. This whole setup is powered by two 12V 12Ah lead acid batteries connected in series to provide a combined energy capacity of 24Ah and voltage of 24 volts. This is the flowchart of the full operation and modes of our wheelchair. Our wheelchair system basically has three modes: autonomous mode, web control mode and the manual mode. Also, provision for speech control has been made using Google's Web Speech API, in which the natural language processing happens on a cloud computer on the commands received from the webcam's mic. And here's the demo of the speech control system. Computer, start. Computer, write. Computer, left. It was seen in the previous frame the wheelchair stopped on its own when it made a left turn as it detected the wall. This is the obstacle detection system where the optical sensors detect any obstacle in the way and through Arduino control the motors. Coming to the autonomous mode or the line follower system. To achieve line follower capabilities, computer vision using OpenCV library was utilized. On the frames received from the webcam, thresholding and masking are applied to only detect the dark or black line or a track over a light background, after which contours are retrieved from the frame using the masked image. Now, to avoid errors of drawing counters around another black object, only the counter with the largest area will be selected, which is obviously going to be the track. And next, the center point of this track is found, and based on the position of the center point on the original frame, wheelchair will be turned right or left or will move forward. This is the ideology behind our line follower algorithm. And here's another demo of the line follower system without any person on the wheelchair. And in this clip, object detection system will also play a role. In the web control mode, the wheelchair can be operated from anywhere in the world and from any internet connected device. To assess this feature, remote video streaming is also provided to help the web user to maneuver the wheelchair with safety and ease. The web controls are written onto a PHP page and a GUI setup similar to the one for manual mode of operation has been implemented. So when a user presses on any of the four buttons, forward, right, left or stop, an AJAX call is made to the server side where a direction post parameter is received, and this parameter is sent to the move function responsible to send commands from the Pi to the Arduino to stop or move the wheelchair forward, left or right. To host this web page, Apache Web Server is used on the Raspberry Pi. The video streaming is made possible using a Flask server onto which the captured frames are uploaded as HTTP format, and an IP address is generated so that this video streaming can be accessed from anywhere in the world. Now a clip will be shown on how to start video streaming and also will show the GUI web page for web controls, after which demo of controlling the wheelchair using web mode will follow. To control our smart wheelchair from the touchscreen interface, a GUI application is developed in Python using the Kinter library. This application uses a menu-based approach and all the commands are touch-based. And here's the demo of our wheelchair in manual mode utilizing this GUI application. Thank you for tuning in.